Another video of the Microsoft Azure series. In this video, we will review the Azure storage and we will talk about what are the differences between different type of Azure storages. We will talk about the blob, file storage, and different type of shares that Azure has. And then finally, we're going to have a hands-on on how to create a Microsoft Azure account and how to add an Azure storage account to it, and finally, how to use different type of storages. Microsoft Azure Storage is a Microsoft managed service that provides durable, scalable, and redundant storage. Microsoft takes care of maintenance and handles critical problems for you. An Azure subscription can host up to 100 storage accounts, each of which can hold 500 terabytes. If you have a business case, you can talk to Microsoft Azure storage support team and get approval for up to 250 storage accounts in a subscription. Azure Storage consists of 4 data services: blob storage, file storage, table storage, and queue storage. Blob storage supports both standard and premium storages, with premium storage using only SSDs for the fastest performance and the best performance possible. Another new feature added in 2016 is cool storage, allowing you to store large amounts of rarely accessed data for a lower cost. During this video, we will look at the 4 Azure storage services. We talk about each one, discuss what they are used for, and show you how to create storage accounts and manage the data objects. We will also touch briefly on securing your application when you are using Microsoft Azure storage. This reference table shows the various kinds of storage accounts that you can get with Microsoft Azure, and actually discusses what objects are used within each. So if you look at that, if you use the service supported account, then you can provide support for blob, files, tables, and queue services. Where the general purpose premium storage account, in this case when the service supported option is chosen, only gives you the availability to go for blob service. And finally, the blob storage account, both hot and cold access tiers provide the blob service within the service supported one. If you go with the types of blob supported account, then basically with the general purpose standard storage account, you will get support for block blobs, page blobs, and appended blobs. Remember, we will discuss all these in more details down this video, so if it is sounding so confusing right now to you, please bear with me and I will discuss those later down this video. So going with general purpose premium storage account and having the types of blobs supported, then you basically can do the page blobs, and finally with the blob storage account for hot and cold service access, you will have the block blobs and appended blobs. More information about the Azure Storage Client tools are available online on the docs.microsoft.azure, and I'm gonna take you there right now for a brief moment so that you can see what you can get from that website. Okay, now we're at the Azure Storage Client tools. This document is updated on 09/5/2017, and coming down here in this table you can get all the information you need to choose your specific Microsoft Azure Storage Client tool. As you can see, you can use the portal itself, you can use the Storage Explorer, and you can use Microsoft Visual Studio Server Explorer, which I'm going to discuss these in a little bit more detail down this video, and based on the type of the information you actually want to store, whether that is different type of blobs, tables, or different type of file shares, you can choose which one is actually the best for you. If you notice, when you are focused on web, then you must go with Microsoft Azure portal, but if you want to have applications downloaded, then that's when you can go with the Storage Explorer or Visual Studio, whichever version is available to you. So more information about the tools is available on this website. I recommend you to go back there and take a look at the tools. The beautiful thing about it is if you click on any of these links, you can simply get more information about what you actually are looking at, and it's going to take you to the websites either to look at the portal online or just to download the Explorer. You notice that the Storage Explorer is free, so you can easily download it to your Windows-enabled machine, whatever you have, and there is also another version of this available for Mac and Linux. There we go. So as you just saw, and you can actually go to the resources and find the tools. You see that we have different type of accesses that each one has its own capabilities, and you as an administrator should decide which one is the best for the situation and the data type that you're using. While you can view and update some data in the Azure portal, the customer experience is not complete. For example, you cannot upload blobs or add and view messages in a queue. In this video, we use the Azure portal and Visual Studio Cloud Explorer and PowerShell to access the data and to show you how to manage your data online. Note that lately Microsoft Azure Storage Explorer team has released a new version that supports all four types of storage objects, blobs, files, and tables. And this tool is a free multi-platform and is available to download on any platform that is available out there. So that is a beautiful thing for those of you who are planning on administering Microsoft Azure storage in future. One tool does it all, and hopefully you can get whatever you want out of it after downloading and installing it. I have to mention that downloading and installing the Storage Explorer is not a part of this video. However, I'm going to create another video later only on the Storage Explorer, so you can take advantage of the step-by-step guides. So now let's talk about the general purpose storage accounts within Microsoft Azure. There are two kinds of general purpose storage accounts. Obviously, as you can see on the slide, standard storage and premium storage accounts. So the most widely used accounts are basically the standard storage accounts, which can be used for all four types of data. Again, those four types of data are blobs, files, tables, and queues. Remember, standard storage accounts use magnetic media to store data, and that is a choice that you are making by default, so you're not getting SSD or hard drives over there. Old school tape drives in the back managed by Microsoft are taking care of your standard storage accounts. We will discuss the difference between the speed and performance later down this video. So the premium storage accounts basically provide high performance storage for page blobs and specifically virtual hard drives or VHDs, which, if you can remember, those are the basis for building your virtual machine. The premium storage accounts use SSD to store the data, which means higher performance, higher speed, reliability is a little bit better, and so. And finally, Microsoft recommends using premium storage account for all of your virtual machines because of the fact that the speed of read and write and the I/O speed of this type of storage is going to help you have a better VM and a better performing VM. So before we move on, I would love to talk about BLOB a little bit. We have been using this term from the beginning of this series of the videos, and I have received multiple questions about, can you talk a little bit more about blobs? And in this slide, we will talk about what is a blob. So basically nothing specific. Blob is just a blob. So the word blob is an acronym for a binary large object. Blobs are basically files like those that you store on your computer. It can be a video file. It can be an image file. It can be a text file. Whatever it is, as long as we don't care about what is inside the file, we can call it a blob. Remember, this is pretty much anything in your computer. It could even be a folder. Like, you can take a folder with multiple different type of files within it and call it a blob. So the main idea about a blob is that the handler of the file For example, in our cases, the database manager or the file explorer or the storage explorer has no way of understanding the file in order to figure out how to deal with it. It might as well be a large piece of coal, a large piece of gold, whatever. But who cares? Who wants to know what it is? Because the handler of the file deals with the file in a way that there is no need for knowing what is inside. For example, if you look at the real life, consider that I bring a box to you, a closed box, and I ask you to take it from me, move it to another building, and put it in the kitchen in that building. In this case, you really don't need to know what is inside that box. And that's how we call it a blob. That's a blob that I just gave you to store it somewhere for me. In this case, you don't need no knowledge of knowing how to deal with whatever is inside. Let's say inside that box is a PlayStation 4. And you don't need to know how to set it up. You don't need to know how to plug it or whatever. You just know there is a box. The box needs to be moved to a point, and you will take care of that part. So the term was coined to refer to big data objects and to connote the problems that they sometimes present in handling them. So basically, it's a full level of abstraction. So when you work with the blobs, you basically are working with the abstract type of data. You just know how to encapsulate it, how to move it, how to decapsulate it. What the payload is, what is inside the payload is none of the handler's business, and therefore this high level of abstraction basically enables you to deal with any type of data with just one system in place. One application that deals with blobs is a database storage of large multimedia devices like movies and television programs. Imagine Netflix really doesn't need to deal with what is the content of a movie when it's just storing them, when it's just streaming them to you. Of course, there are auditors who look into the movies and talk about the content, but that's out of the scope of this discussion. In this case, we're just talking about how to store them and how to move them from point A to point B. And if that comes to the play, we just call them a blob. So now you see how blob storage could be useful. Because if you are storing a file of Excel type, Azure doesn't really need to be able to understand what Excel file is. It just stores it, and that's what it does. So now that we'll learn more about the blob, let's move on and talk about the blob storage accounts within Microsoft Azure. The blob storage account is a specialized storage account used to store block blobs and append blobs. We will talk about what an append blob is. So you can't store page blobs in these accounts at all. Remember, this is only about the block blobs and append blobs. And this means you will not be able to store VHD files because VHD files are the page blobs. These accounts basically allow you to set an access tier to hot or cool, and the tier can be changed from any time. Remember, when we talk about hot or cool storage, basically we talk about the frequency of access request that comes in for that type of storage. So you can change it at any time. Let's say if you start with a cool blob and just put your stuff there, let's say your archive files in there, and those archive files are not even used by your business, and then down the road your business decides to go back to that project and use those files, you can simply switch it from cool to hot. But one may ask, why should I even set them to cool or hot from the get-go? Okay, now let's see why. So be very careful and specific about these two sentences down here. It may sound a little bit confusing at first, but if you just try to analyze it with yourself, it's going to become an easily understandable subject. So let's read it together. For blobs stored in the hot access tier, you pay a higher cost for storing the blobs. Let's stop here. So if that is a hot access tier, it's expensive. Now, why should we even use this expensive account? Here is the answer. Because the cost of accessing the blob is much lower. So you pay a big down payment for the storage itself, but for every time that you access the information, you pay much lower price. And that's what's gonna become much lower pay, final pay, for the total cost of ownership for this type of a storage account for you. Because your users are frequently accessing this, that lower price of access actually is going to cover the higher price of initial cost. For blobs stored in a cool access tier, you pay a higher cost of accessing the blob, but the cost of storage is much lower. That means you have much lower initial fee, but then each time you access this type of storage, the cool storage, you're going to pay more. So again, because your users are not going to go and frequently access the data in this type of storage, that means the number of those expensive accesses is going to be low, and therefore the higher cost of those accesses is going to get compensated within the lower cost of initialization. So whether you go with the hot tier or the cool access tier, if you do a calculation over how many access per month or how many access per period you're going to have, then you can come up with a better idea with which one of the tiers is your tier. The Azure Blob service gives you the ability to store files and access them from anywhere in the world by using URLs, the REST API, or one of the Azure SDK storage client libraries. Storage client libraries are available for multiple languages including .NET, Node.js, Java, PHP, Ruby, and Python. To use the Blob service, you have to create a storage account, and then once you have a storage account, you can create containers which are similar to folders and then put blobs in the containers. You can have an unlimited number of containers in a storage account and an unlimited number of blobs in each container, up to the maximum size of the storage account. Absolutely. So that makes sense. Your storage account has a maximum size, and that's going to be the limit for the number of the containers or whatever you have, which there is a limit for the maximum size of a storage account, even if you are willing to pay. So the max you can go for is 500 terabytes. The Blob service supports only a single level hierarchy of containers. In the other word, containers cannot contain other containers. It's very important to understand. You're going to see that we can have a hierarchy of storage, which is going to be achieved through abstraction, but in reality, there is only one layer of containers. It's like you have some boxes in your garage, but then you cannot put another box within those boxes. So you can have as many boxes as you want, any shape, any size, but no box can contain another box within it. So no two boxes within one box or stuff like that. And that's how the containers actually work. Azure supports three kind of blobs. You can have block blobs, page blobs, and append blobs. Block blobs are used to hold ordinary files up to 195 gigabytes in the size of 4 megabytes times 50,000 blocks. The primary use for block blobs is the storage of files that are read from the beginning to the end in a consequential way, such as media files or image files. So basically, if you have a video file and you want to read the file, you cannot read to a specific point of the video file. You basically start from the beginning of it and you go all the way till you finish the file and copy it. Same story is with the image files. They're named block blobs because the files larger than 64 megabytes must be uploaded as a smaller blocks, which are then consolidated or committed into a final blob. So this is very important to remember. The maximum size of the block for the block blob is 64 megabytes. Therefore, larger files are going to be chunked down and then consolidated later to a final blob. So page blobs are used to hold random access files up to 1 terabytes in size. Page blobs are used primarily as the backing storage for the VHDs used to provide durable disk for Azure virtual machines or Azure VMs, as we discussed in the past. The infrastructure as a service feature in Azure Compute basically takes a lot of advantage of the page blobs. They're named page blobs because they provide random read or write access to 512 byte pages. So, as you can see at this point, you can go to any place in the blob, read, access, or write. While in the block blobs, you couldn't do that. You have to go from the beginning to the end. And finally, the append blobs are made up of blocks like block blobs, but they are optimized for append operation. These are frequently used for logging information from one or more sources into the same blob. For example, you might write all of your trace logging to the same append blob for an application running on multiple virtual machines. A single append blob can be up to 195 gigabytes. So let's review what we looked at. So we have block blobs, page blobs, and append blobs based on the need that you have for each one of these storages. To access these blobs, you can actually use a URL address. The URL address should have this format. So the HTTPS for sure, because it's a secure access. And then you will start with // storage account name. That is your account name. Like right now for you is the free account for LE or whatever. And then you put blob.core.windows.net. This is a constant syntax that should show there no matter what. And then a slash the container name and a slash the blob name. So very simple and very easy. The blob service basically is available to you through this HTTPS link. Remember, the blob service supports only a single physical level of container. However, it supports simulation or abstraction of a file system with folders within the containers by allowing blob names to contain the / character. The client APIs provide support to traverse the simulated file system. For example, if you have a container called animals and you want to group the animals within the container, you could add blobs named cats, let's say tuxedo.png, cats, marmalade.png, and so on. The URL would include the entire blob name, including a subfolder, and it will be ending up like this. So as you can see, the first one is addressing the tuxedo name, and the second one is accessing the marmalade name. Both are the cats, both are within the animals, and in actuality, they physically are not in that hierarchy, but it is abstracted to the hierarchy. So when looking at the list of blobs using a storage explorer tool, you can see either a hierarchical directory tree or a flat listing. Remember again, that is just an abstraction. The directory tree would show cats as a subfolder under animal and would show the .png files in the subfolder. The flat listing would list the blobs with the original names, cats / tuxedo.png and cats / marmalade.png. Okay, so you also can assign a custom domain to the storage account, which changes the root of the URL. So you could have something like what you see here, http / storage.companyname.com / container / blob name. So as you can see here, the abstraction actually eliminates the cross-domain issue when accessing files in a blob storage from a website, because you could use company domain for both. Blob storage also supports cross-origin resource sharing, or CORS. For those of you who need more information on this, I'm going to have another video explaining this later down the road to help with the type of cross resource usages that we show here. But note that at this time, Microsoft does not support using a custom domain name with HTTPS. So what I want you to carefully look at is right now when we're talking about the custom domain name, there is no S, and this is not as secure as it was when we were talking about using the storage account name, which is, if you can see, the HTTPS is right there for any of these URLs to the storage accounts that we have. It's very important to remember, and when we talk about the security of Microsoft Azure instance, we basically are going to come back to this and discuss this a little bit further down the road. Okay, so now let's talk about the file storage. The Azure file service basically enables you to set up highly available network file shares that can be accessed by using the standard server message block or SMB protocol. This means that multiple VMs can share the same files with both read and write permission access. The files can also be accessed using the REST API or the storage client libraries. The file services removes the need for you to host your own file shares in an Azure VM and go through the tricky configuration required to make it highly available. This actually is one of the huge benefits to the file sharing on Azure. Remember when we were talking about infrastructure as a service, we discussed about creation of a VM, and we said you can host any service that you want from within the VM. One of those services could be a file share. You can create a directory on that VM and share the files from that directory with any other instances of resources within your VNet. However, the trick here is if your VM goes down, if your VM is down, if you shut it down, or for any reason you're maintaining, updating, doing that, remember this is not regarding the scalability or availability sets that we discussed before. It's about what you decide as an admin. Consider you have more than 20, 30 VMs running and you're taking care of those, and one of them has some share items with the other VMs. When you turn one of them down, manually, which in this case the availability set is not going to help anymore because you decided for the server to be unavailable, you basically have made all of those shares unavailable at the same time. Also, if you have a specific permissions set for the users on how they can access that specific VM or how they can remote to that specific VM, then you have put limitations which are going to be a boundary around that file share that you created within the VM, which means your hands are tied according to the restraints and constraints that you yourself basically put on the user access to that VM as a whole. And this makes managing a file share much more difficult and much more complicated. However, when you're using a file storage as a share, that file storage basically is not within any of the virtual machines you have. So every resource within your network, within your virtual network, has access to those resources. Regardless of what the VM ACL is, regardless of what conditions you have on that VM. So that is a pretty neat function that you can have using the file storage instead of having a file share created by you yourself within a VM that you created. So one thing that's really special about Azure file shares versus file shares on the on-premises is that you can access the files anywhere in the world by using a URL that points to the file similar to the BLOB storage URL displayed before. To do this, you have to append share access signature or SAS, which I will talk about the share access signatures when I'm talking about the security. For now, just know that is over there. And later down the road, when we talk about the security, we definitely are going to go into much more detail about the SAS. And Also, on top of what we already discussed and we said how great are the file shares, let's see some of the scenarios that you can use the file shares on those. So many on-premises applications use file shares. This make it easier to migrate those applications that share data to Azure. And if you mount the file share to the same drive letter that for the on-premises computer and the application is using, the part of your application that accesses the file share would work without any changes, and it's going to be transparent to the application. The other perk of it is configuration files can be stored on a file share and accessed by multiple VMs. This makes your deployment easier, this makes your management easier, and it actually facilitates the process of managing a VNet on an IaaS. Uh, every VM can go in, take a look at the configuration file, make a copy, bring it in, apply it, and move from there. So you can even set up a configuration syncing schedule and let your VMs basically sync themselves with whatever is in the configuration file. And every time you want to change something within your network, you just need to change that one on the file share. And guess what? All the VMs are going to inherit that from the file share and go from there. One other perk is the diagnostic logs. So basically, you can have diagnostic logs, metrics, crash dumps, and anything else, and you can save them into a file share to be processed and analyzed later, and they can come from every single device that you have in your VNet to this specific repository. And this way, you're going to make the job of your auditor and administrator much easier because they just need to log into the file share, look at the logs and metrics that they have, and decide what they have to do to manage the network better. The other perk is about the tools and utilities. So tools and utilities used by multiple developers in a group can be stored on a file share to ensure that everyone uses the same version and that they're available to everyone in the group, no matter their access, no matter their permissions, no matter the status of the VM and anything else. So basically, it's going to remove the fact that some of your VMs may turn into a single point of failure regarding the access if and only if a user doesn't have correct permission or correct access authentications into that specific server. Let's say you are running a company that basically is developing a piece of code, and everyone needs to look at a design template that your software designer has created. Um, so most of these users, they really don't need to have their head inside any of your VMs if they only want to take a look at the template. Therefore, what's better than keeping that template on a file share and let those actually have access to the file share and go from there? This adds to your availability, this adds to your confidentiality, and this actually adds to the integrity of information because everyone is using the exact same copy of the design template you want. And if you noticed, when you add to confidentiality, you add to availability, and you add to integrity at the same time, you basically are adding to the all three corners of the security triangle, which means you have a much more secure system compared to the traditional way of doing it. To make the share visible to a VM, you just mount it as you would any other file share. So then you can access it through the network URL or the drive letter to which it was assigned. The network URL has the format of / storage name .file.core.windows.net. Remember this piece of information, files.core.windows.net, which basically is the name of the server, name of the service within Microsoft Azure namespace, is a method that you can add it to any storage account name and use whatever property comes with it. And then you have a / share name. Look at this. In this case, we are all using all backslashes, not forward slashes. So after the share is mounted, You can access it using the standard file system APIs to add, change, delete, and read directories and files to that. So let's see how we create a view actually. So to create or view a file share or upload or download files to it from outside Azure, you can use multiple different tools. You can use the Azure portal, you can use the PowerShell, you can use the Azure command line interface, the CLI, you can use the REST APIs or REST interfaces, and you can even use one of the storage client libraries or even use the AZ copy. And also there are several storage explorers that we discussed at the beginning of this video. Let's take a look at the AZ copy pretty quick so you guys can see the tool. So here is the article on the AZ copy, which helps you to transfer data. This one is updated on January 2nd, 2019. Takes half an hour to read. It's pretty much straightforward. Basically, it talks to you about how to download the tool and install it on your computer, and then basically walks you through how to run different commands. In order to start working with the AZ copy, you basically need to have already created your Azure storage account and have some kind of storage account, whether BLOB or file share or whatever in there, and then you can use this tool to upload or download or manipulate your information over there. It's a pretty straightforward tool. As you can see, the syntax even looks like what you really have on your computer, and then you basically call the AZ copy command with its format and do whatever you want with it. Pretty simple and straightforward. So I'll let you guys play with that later down the road. Just remember that is under the docs.microsoft.com. And again, remember all of these documents that I'm showing to you within this videos are available on the docs.microsoft.com. If you don't have the URL directly, you can just search for the title, and there is a unique information connected to that title that is going to show up to you and help you understanding and implementing that specific part of the game. So let's come back to our slide set and continue with some tips about using a file share. So the first thing is, remember that when using SMB 2.1, the share is available only to virtual machines within the same region as the storage account. This is important to understand. This is because SMB 2.1 basically does not support encryption. When your information travels between two different regions, within Microsoft Azure infrastructure, it has to be encrypted or it cannot leave the region. That's one of the mandatory requirements of Microsoft Azure transfer. It is transparent to the user. You don't need to care about it, but you need to understand using SMB 2.1, you cannot have these two within two different regions because then the information cannot transfer. Again, virtual machine and the storage account should be within the same region if you're using SMB 2.1. Also, if you have forgotten what is SMB, I'm reminding you that SMB is server message block, and it's very similar to Common Internet File System or CIFS. Basically operates as an application layer networking protocol mainly used for providing shared access to files, printers, and serial ports and miscellaneous communications between nodes on a network. It also provides an authenticated inter-process communication mechanism, and most usage of SMB involves computers running Microsoft Windows, where actually in the past it was known as Microsoft Windows Network before the introduction of the Active Directory, corresponding Windows services, and the LAN manager server services. Anyway, coming back here, the version of 2.1 of the SMB basically is available for the VMs and the shares on the same region. So that's important, and you should not forget it, because there have been some instances of people who basically contacted Microsoft with this issue that my VM cannot communicate with my storage account while everything was set up properly. Only one thing, they were using SMB 2.1 and the server was in a different region. So when using SMB 3.0, the share can be mounted on VMs in different regions, or even a desktop. Note that to mount an Azure file share on the desktop, port 445, which is the SMB port, must be open. So you may need to negotiate that with your company because almost most of ISPs and companies close that 445 to stop the possible attackers and hackers. Uh, Again, it is important to remember that 445 for the traffic should be open. Most possibly your admin or your company is not going to be very happy with you opening up their 445. But again, if you want to have that as a share on a desktop, then that's cool. And an implementation of that is if you really don't trust Microsoft with your information, then you keep it local, keep the share on your desktop or on your server and within the premises, and share it through the desktop sharing through SMB port and let your VMs have access to it. So if using a Linux VM, you can only mount shares available within the same region as the storage account. This is because while the Linux SMB client supports SMB 3.0, it does not currently support encryption. So going back to what we said at the beginning, it's all about the encryption and the fact that unencrypted information cannot traverse between regions of the Microsoft Azure infrastructure. And since Linux and SMB 3.0 do not support encryption, that means they have to be within the same regions. The Linux developers are responsible for SMB functionality, and they have agreed to implement this, but there is no known time frame. So the point is, you never know when actually it's going to happen. Same story happens with Mac. So if you're using a Mac, you can't mount Azure file shares because Apple's Mac OS doesn't support encryption on SMB 3.0. So Apple has agreed to implement this, and again, there is no known time frame. So as of now, the rule of thumb is if you are using a Linux or a Mac OS, make sure your online Azure storage account and the VMs are within the same region. One problem that usually arises and is very difficult to manage is if you remember from the other video, for the sake of availability, we wanted to have servers in different regions. So when you are setting your availability set, you have to make sure those different availability regions, which are different from the Azure regions, are within the same region. If you choose one of your servers to be here in the United States and the other server all the way out to Singapore, then the problem is they're very available. They are really available because of the fact that it's least likely for both of the locations to be hit by any disaster. But at the same time, your storage accounts are not really working on the if you are using Mac or Linux. So basically, use Windows if you want to do that, and everything is supported. Mac or Linux, be careful on how you set up your availability sets. Because, as I said again, that's where mainly the problem is going to show itself. So let's move on with more perks on Microsoft Azure storage accounts. You can access the data from anywhere by using the REST APIs rather than SMB. That is actually nice. So if your developers don't go for SMB, then you have no problem of encryption because REST API is taking care of the encryption itself, and you don't need to be worried about that. Other thing is the storage emulator does not support Azure files. That's another thing. So be careful when you're using storage emulators on your local computer or on any of your infrastructure as a service virtual machines to make sure the access to the shares are available. The next thing is the file shares can be up to 5 terabytes. You cannot have larger than 5 terabytes. If that is the case, if you're storing tons of videos, movies, and so on, if you're Netflix, HBO, Hulu, or whatever other name that they didn't pay me to advertise them over here, if you're one of those, make sure you have multiple shares set up so you can have chunks of 5 terabytes. The other thing is throughput is up to 60 megabits per second per share. So that's possibly another good reason to break down your shares into smaller pieces and locate them in different locations. And the size limit of files placed on the share is 1 terabyte. So you can have 5 times 1 terabyte in a share. And then there are up to 1000 IOPS, which of size of 8 kilobytes per share, that you basically can have in a Microsoft Azure storage account. And again, if you don't remember, IOPS is input output operations per second, and that's basically a definition of the speed that you can have. Let's move on and talk more about how using a file share could be actually amazing for us, and that brings us down to the concept of the Active Directory based authentications. Those in the access control list ACLs are not currently supported, but it is expected that they will be supported at some times in the future. So for now, the Azure storage account credentials are used to provide authentication for access to the file share, and this means anybody with the share mounted will have full read-write access to the share. This is a huge drawback as of today for those who really want to control their access to the shares, and that is one of the drives that pushes people back to go and use within VM shares. So we talked about the benefits of having the shares instead of file shares within the VMs. In this case right now, we are going back to the fact that if you really need the access control, at this point you have no other option but to take them back inside the VM and manage those. If you remember, within the infrastructure as a service video, we were talking about there are some requirements, there are some services that if you want to implement, you have no other option but to go for this lower level of abstraction, which is infrastructure as a service, and this is a good example of it. And finally, last but not the least, is for the files that are accessed repeatedly, you can maximize performance by splitting a set of files among multiple file shares. And the reason is because the speed is limited to 60 megabits per second, megabytes per second. You have to remember that it is going to be your maximum speed per share, and that 60 megabytes per second basically is as all you have. So now if you break it down into 2 share, you basically are increasing the speed all the way up to 120 megabytes per second, and that's what to actually consider. So the next thing we're going to talk about is going to be the table storage, which is absolutely another type of storage. However, we're not done with the file share and blob yet. We're going to come back to these concepts later down the road when we're talking about the security more often, and that is basically as much as we need to do for now. Again, I'm going back to remind you that the throughput is up to 60 megabytes per second per share, and if I have mispronounced it as megabits before this, please ignore that. The correct is megabytes, 60 megabytes per second. So, table storage is another type of Azure storage account. So, Azure Table Storage is a scalable NoSQL data store that enables you to store large volumes of semi-structured data. Remember, this semi-structured non-relational data is kind of different from what you have learned in the SQL database. So each table has a single clustered index that can be used to query the data quickly. And you also can access the data by using link queries and OData with the WCF data services or .NET libraries. A common use of table storage is for diagnostic logging, and to use table storage, you have to create a storage account, and once you have a storage account, you can create tables and fill them with data. A table stores entities, which basically are the rows, and each of which contains a set of key slash value pairs. Each entity has three system properties: a partition key, a row key, and a timestamp. So, uh, the differences between NoSQL and SQL have put them in a different spotlight, each one in a different spotlight for where to be used and for which purposes to be used. Let's look at some of those differences in the high-level abstraction. SQL databases are primarily called as relational databases or RDBMS, whereas the NoSQL database are primarily called as non-relational or distributed databases. Other is SQL databases are table-based databases, whereas NoSQL databases are document-based, key value pairs, graph databases, or wide column stores. This means that SQL databases represent data in the form of tables which consist of an n number of rows and different columns of data, whereas NoSQL databases are the collection of key value pairs, documents, graph databases, or wide column stores which do not have standard schema or definitions which it needs to be adhered to. So they are more free compared to the rules and regulations you have on the SQL side. So also SQL databases are vertically scalable, whereas the NoSQL databases are horizontally scalable. SQL databases are scaled by increasing the horsepower of the hardware, while NoSQL databases are scaled by increasing the database servers and the pool of resources to reduce the load. Which does it ring a bell? Isn't that how Microsoft Azure VMs actually scale up? That's another good reason that why we do the tables in Microsoft. Anyway, SQL databases used SQL or structured query language for defining and manipulating the data, which is very powerful. And in NoSQL database, queries are focused on collection of documents. Sometimes it is called as UNQL or unstructured query language. And the syntax of using UNQL varies from database to database depending on which database you're dealing with. Some SQL database examples are like MySQL, Oracle, SQLite, Postgres, MS SQL, and NoSQL database examples are like database or MongoDB, Bigtable, Redis, RavenDB, Cassandra, HBase, Neo4j, and CouchDB. Um, for complex queries, SQL databases are a good fit for complex query intensive environment, whereas the NoSQL databases are not good fit for complex queries. This is important to remember. So the choice over the database usage should be also looking at what type of queries you're running on that database. So on a high level, NoSQL don't have a standard interface to perform complex queries, and the queries themselves in NoSQL are not as powerful as SQL query language is. For the type of data to be stored, SQL databases are not best fit for hierarchical data storage, but NoSQL database fits better for the hierarchical data storage as it follows the key value pair way of storing data similar to JSON data. So a NoSQL database are highly preferred for large data sets like big data. HBase is an example for this purpose. Looking at it from the perspective of scalability, in most typical situations, SQL databases are vertically scalable, and you can manage increasing load by increasing the CPU, RAM, SSD, and etc. on a single server, while the NoSQL databases are horizontally scalable, as we just discussed, and you can just add a few more servers easily in your NoSQL database infrastructure to handle the larger traffic. For high transactional based applications, SQL databases are best fit for heavy duty transactional type applications, as it is more stable and promises the atomicity as well as integrity of the data, while you can use NoSQL for transactions purpose. It is still not comparable and scalable enough in high load and for complex transactional applications as SQL is. From support perspective, excellent support is available for all SQL databases from their vendors. There are also a lot of independent consultations and people who actually work in SQL who can help you with any SQL database for very large scale deployments, and no matter how you want to deploy it. For some NoSQL databases, you still have to rely on the community support. This is newer. There is not a lot of vendor support out there, and the outside experts are very limited, and the availability of those outside experts are not really guaranteed. And when you look at it as the properties perspective, SQL database emphasizing on asset properties, atomicity, consistency, isolation, and durability, whereas NoSQL database follow Brewer's cap theorem, which is their consistency, availability, and partition tolerance. That's just how they look at it. And finally for the DB types, on a high level, we can classify SQL databases as either open source or closed sourced from commercial vendors. NoSQL databases can be classified on the basis of way of storing data as graph database, key value store databases, document store databases, column store databases, XMLs, and so on, so on, so on. So as you can see, you cannot really say which one is the better database. NoSQL obviously is a newer guy and is trying to catch up with more robustness and being available for solving complex solutions. But even now, there are applications of data storage that NoSQL is much better to work in. Applications like social media, Internet of Things, mobile apps, gaming, and so on. While SQL is still better for data marts, enterprise calculations, and where you need really complex queries to be run on information, something like data mining and so on, you still get a better result from SQL. But going back to what we had over here, when we talk about the table storage, you basically are storing a NoSQL database within your Azure storage account. So each of these tables stores rows, as we said, each of which contains a set of key value pairs. Each entity has three system properties: a partition key, a row key, and a timestamp. The partition key and row key combination must be unique. Together, they make up the primary key for that specific table. The partition key property is used to shared partition the entity across different storage nodes and allowing for load balancing across the storage nodes. All entities with the same partition key are stored on the same storage node. The row key is used to provide uniqueness within a given partition. To get the best performance, you should give a lot of thought to the primary key and row key and how you need to retrieve the data. You don't want at all for your data to be in the same partition, nor do you want each entity to be in its own partition. So you need to come up with a combination of what is best for the situation that you actually are looking at that specific moment. The Azure Table Service provides a scalability targets for both a storage account and partitions. The timestamp property is maintained by the Azure and it represents the date and time the entity was last modified. Again, it is important to remember that we don't touch the timestamp property, it is managed by the Azure. Azure Table Service uses this to support optimistic concurrency with e-tags, and that's why it doesn't let us actually touch it at all. In addition to the system properties, each entity has a collection of key value pairs called properties. This is no schema, so this is not SQL, remember that. So the key value pairs of each entity can contain values of different properties. For example, you could be doing logging and one entity could contain a payload of customer ID, customer name, request date and time, and the request itself. And the next could have customer ID, order ID, item count, code, date and time, blah, 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 and so on. So you can stop wherever you want. You can create any type of entities in this transaction. And the only limitations you have is that you can store up to 252 key value pairs in each table entity. That's the only limit you're looking at. The number of tables is unlimited up to the size limit of the storage account. And these tables can actually be managed by using the storage client library. The table service also supports a REST API that implements the OData protocol and also gives you a way to access the tables through using the storage client libraries. So look at this URL link that I have in here. This basically is the OData protocol accessing, and as you can see, we don't have HTTPS, we only have HTTP, and then we have the storage account name, which is going to be your account name. Again, the property of table.core.windows.net comes to the play, and finally the table name, and then you have it. So the next object that we're going to talk about is going to be the queue storage, and we will start here. The Azure Queue Service basically is used to store and retrieve messages. Remember, we usually don't use queue storage for media files or large company files and so on. It is best optimized to be used for retrieving messages. Queue messages can be up to 64 kilobytes in size, and queue can contain millions of messages up to the maximum size of the storage account. So queues generally are used to create lists of messages to be processed asynchronously. The queue service supports best efforts first in, first out FIFO queues. For example, you might have a background process, such as a worker role or Azure web job, and this background process continuously checks for messages on a queue. When it finds a message, it processes the message and then removes it from the queue. One of the most common examples is image or video processing. Let's say you have a web application that allows a customer to upload images into a container in a blob storage. Your application needs to create thumbnails for each image. Rather than making the customer wait while this processing is done, you put a message on a queue with the customer ID and customer name. Then you have a background process that retrieves the messages and parses it to get the customer ID and the customer name. The background process then retrieves each image, creates a thumbnail, and writes the thumbnail back to the same blob storage container as the original image, And after all images are processed, the background process removes the message from the queue. Remember, it uses the message in order to maintain the right process. And basically, after that is done, it is going to delete that. So what if you need the message to exceed 64 kilobytes in size? In that case, you could write a file with the information to a blob in the blob storage and put the URL to the file in the queue message. The background process could retrieve messages from the queue and then take the URL from those messages and read the file from the blob storage to do the required processing. Azure queues provide at least once semantics in which each message may be read one or more times. But the minimum of one is guaranteed for the message to be read. This makes it important that all processing of the messages be idempotent, which means the outcome of the processing must be the same regardless of how many times the message is basically processed. When you retrieve messages from a queue, it is not deleted from the queue. So you have to delete it when you're done with it. This is another thing to remember. When the message is read from the queue, it becomes invisible. The invisibility timeout is the amount of the time allowed for the processing of the message. If the message is not deleted from the queue within this amount of time, it becomes visible again for processing. In general, you want to set the property to the largest amount of time that would be needed to process a message, so that while one instance of a worker role is processing it, another instance doesn't find it as visible on the queue and then try to manage it. You don't want to read the message from the queue, delete it from the queue, and then start processing it. Why? Because in case the receiver fails, the queue entry will never be processed. And that's why we set it back to invisible and wait for the handler to take care of it. And if it failed, basically we have the message available. It is just invisible and it's going to turn automatically to visible so that the next handler can take care of it. Leaving the message on the queue but invisible until the processing has completed handles the case of receiving process failing eventually. So the message will become visible again and will be processed by another instance of the receiver if the previous instance of the receiver failed to complete it and set it out. You can simulate a workflow by using a different queue for each step. A message can be processed from one queue from which it is deleted on completion, and then that processing can place a new message on a different queue to initiate processing for the next step of the workflow. You can also prioritize messages by using queues and processing the messages in those queues with different priorities. The queue service provides poison message support through the DQ count. The concerns is that what if an invalid message could cause an application handling it to crash? So a hacker, an attacker, can actually inject or poison a message into your queue and make your application crash, and that actually makes your application unstable. So in order to avoid that, this is how we deal with that. Such a message, which is referred to as a poison message, can be prevented by checking the queue and create a DQ count for each message. If this exceeds some level, the processing of the message should be supported. If not, the message should be deleted from the queue and a copy inserted in a separate poison message DQ for offline review. You could process those entries periodically and send an email when an entry is placed in your queue, and you let your administrator know that they have to take a look at it. To understand it better, remember the time to leave property of a TCP header. That is a similar logic to what we had over there. So I think that's pretty much what we need to talk about the queue right now at this level of the video. And let's move on to redundancy and talk about what happens if the storage node on which your blobs are stored fail. So, as I said, the question is, what if the storage node on which your blob storages are saved into fails? Fortunately, Azure supports something called redundancy. There are 4 choices for redundancy, and you specify which one to use when you create the storage account. You can't change the redundancy settings after they're set up. This is hugely important. Remember, you cannot change the redundancy setting after they're set up, except in the case of zone redundant storage. So the redundancy services are locally redundant storage or LRS, geo-redundant storage or GRS, read access geo-redundant storage or RAGRS, and finally zone redundant storage or ZRS. Let's go to LRS. Azure Storage provides high availability by ensuring that 3 copies of all data are made synchronously before a write is deemed successful. These copies are stored in a single facility in a single region. The replicas reside in separate fault domain and upgrade domains. This means the data is available even if a storage node holding your data fails or is taken offline to be updated. When you make a request to update storage, Azure sends the request to all 3 replicas and waits for successful responses from all of them before responding to you. So when you receive the response from the Azure, that means all 3 replicas are actually updated successfully. This means that the copies in the primary region are always in sync. LRS is less expensive than GRS, and it also offers higher throughput. If your application stores data that can be easily reconstructed, you may opt for the LRS. Next, we talk about GRS. GRS makes 3 synchronous copies of the data in the primary region for high availability. And then it asynchronously makes 3 replicas in a paired region for disaster recovery. Each Azure region has a defined pair region with the same geographical or geopolitical boundary for GRS. For example, West United States is paired with East United States. This has a small impact on a scalability targets for the storage account. The GRS copies in the paired region are not accessible to you, and GRS is best viewed as disaster recovery for Microsoft rather than for you. In the event of a major failure in primary region, Microsoft would make a GRS replicas available. But this has never happened to date, which actually is good to know. So RAGRS basically is a GRS plus the ability to read the data in the secondary region, which makes it suitable for partial customer disaster recovery. If there is a problem with the primary region, you can change your application to have read-only access to the paired region. The storage client library basically supports a fallback mechanism via Microsoft.Windows Azure.Storage.Retry policies. And what it does is it tries to read from the secondary region, and the secondary copy of the primary copy can't be reached. It is just a read-only version. This feature is built in for you. Your customers might not be able to perform updates, but at least the data is still available for viewing, reporting, or etc. You also can use this if you have an application in which only a few users can write to the data, but many people read from the data. You can point your application in a way that writes the data to the primary and basically reads the data from the secondary. This is a good way to spread out the performance when accessing the storage account. So finally, let's talk about ZRS. This option can only be used for block blobs in a standard storage account. It replicates your data across 2 to 3 facilities, either within a single region or across the regions. This provides higher durability than LRS, but ZRS accounts do not have metrics or logging capabilities, which is going to be a problem for those who want to monitor and increase the performance based on how the use changes. So finally, we have to talk a little bit more about security on Azure so that we have completed our storage accounts. Azure Storage provides a set of security features that help developers build secure applications. You can secure your storage account by using Role-Based Access Control or RBAC and Microsoft Azure Active Directory or Azure AD. You can use client-side encryption, HTTPS or SMB 3.0 to secure your data in transit. You can enable a storage service encryption, and Azure Storage Service will encrypt data returned to these storage accounts of yours. OS and data disks for VMs now have Azure Disk Encryption that can be enabled. And secure access to the data basically can be happening through any of the communication objects or plain objects such as blobs that can be granted using a shared access signature or SAS within Microsoft Azure. We will talk more in detail when it comes to the security, but this part at the end of the storage security is just related to how to secure the storage, not the entire instance of the Azure, which is going to be a completely different video. The first thing to think about is securing your storage account yourself. So there are storage account keys. Each storage account has 2 authentication keys, a primary and a secondary, either of which can be used for any operation. There are 2 keys to allow occasional rollover of the keys to enhance security. It is critical that these keys be kept secure because their possession, along with the account name, allows unlimited access to any data in the storage account. Say you're using key 1 for your storage account in multiple applications, you can regenerate key 2 and then change all the applications to use key 2, test them, and deploy them to the production. Then you can regenerate key 1, which removes access for anybody who is still using it. A good example of when you might want to do this is for your team uses a storage explorer that retains the storage account key, and someone leaves the team or the company and you don't want them to have access to your data after they leave. This can happen without a lot of notice, so you should have a procedure in place to know all the apps that need to change the permission are actually changed, and then practice rotating keys on a regular basis to that it's simple and not a big problem when it's necessary to rotate keys in a hurry. So pretty basic, just have a key, let applications use that key in the development. When it becomes to the product release, Now you're regenerating that key again, using another key for the application and assigning that key to the new applications in development. And this way, at any given time, you can simply remove access with just regeneration of a key. With Resource Manager RBAC, you can assign roles to users, groups of applications, and so on and so on. The roles are tied to a specific set of actions that are allowed or disallowed, as we discussed in the previous videos. Using RBAC to grant access to a storage account only handles the management operation of that storage account and nothing else within your Azure subscription. You can't use RBAC to grant access to objects in the data plane like a specific container or file share. You can, however, use RBAC to grant access to the storage account keys, which can then be used to read or write into the data objects. For example, you might grant someone the owner role to the storage account. This means they can access the keys and thus the data objects themselves. And they can create storage accounts and do pretty much anything that they want to do. And you might grant someone else the reader role. This means that they can actually just read the information about the storage account, and they can read resource groups and resources, but they can't access to the storage account keys, and therefore they can't access the data objects. So as you can see, if your user needs to have access to the data objects, they should have access to the data keys. If someone is going to create VMs, you must grant them the virtual machine contributor role, which grants access to retrieve and use the storage account keys, but not to create the storage account themselves. They need the keys to create VHD files that are used in the VM disk, and therefore you have no other option but to give them access. But at the same time, with that level of access, they cannot actually manipulate anything besides creating the VM disk. The Azure Key Vault itself is there to help you safeguard cryptographic keys and secrets used by Azure applications and services, as we discussed before. You could store your storage account keys in an Azure Key Vault. What does this mean for you as a user is that while you can't control access to the data objects directly using Active Directory, you can control access to an Azure Key Vault using Active Directory. So this solves the problem basically. So what you do is put your key inside the Azure Vault and then control the access to the Azure Vault. So this way Active Directory comes to your help and solves the ACL problem that you have. So for example, let's say you have an application running as a web app that uploads files to a storage account. So you want to be really sure nobody else can access those files. To do this, you add the application to Azure Active Directory and grant the application access to the Azure Key Vault with data storage account keys within the Key Vault. After that, only that application can access those keys. This is much more secure than putting the keys in the web.config file where a hacker could easily get to them and abuse them against you. So you can also secure access to your data, which basically there are two ways to secure access to your data objects. We just talked about the first one by controlling the access to the storage account key, and the second way to secure access is by using shared access signatures and stored access policies. A shared access signature, or SAS, as we mentioned that prior in this video, is a string containing a security token that can be attached to the URL for an asset that allows you to delegate access to specific storage objects and to specify constraints such as permissions and the date-time range of access. You can grant access to blobs, containers, queue messages, files, and tables. Actually, with tables, you can grant access to the specific partition keys. For example, if you were using geographical state for your partition key. You could give someone access to just the data for California and no other state's data. As you can see, there are a lot of implementations for this type of access control, which one of them is basically what you do with, for example, the elections. So you can have a specific users that they can have access to California ballots, while the same people can have no access to Washington's ballots and so on. So you can also fine tune these accesses by separation of concerns. You can give a web application permission to write messages to a queue, but not to read them or delete them and so on. Anyway, at the end of the day, managing and controlling the access and security to your storage data is nothing more than what you used to do with the ACLs in the past, but within the way that Azure wants you to do it. We will discuss this more when we are more focused on security and the Azure security towards the end of this series of videos. The other thing is you can secure your data in transit. As you know, we have two types of data: data in transit and data at rest. And data in transit is basically another consideration when storing your data in Azure storage. The consideration is securing the data when it is being transferred between the storage service and your application. So first, you should always use the HTTPS protocol, which ensures secure communication over the public internet. Note that if you're using SAS, there is a query parameter that can be used that is a specific, and only the HTTPS protocol can be used with that specific SAS header. Excuse me, the SAS URL. For Azure file shares, SMB 3.0 running on Windows encrypts the data going across the public internet. When Apple and Linux add security supports to SMB 3.0, you will be able to mount file shares on those machines and have encrypted data in transit too. But before they actually announce that encryption is added to SMB 3.0 for those platforms, you have to be careful about the security of the data in your transit. In transit. So last, you can use the client-side encryption features of the .NET and Java storage client libraries to encrypt your data before sending it across the wire. When you retrieve the data, you can then unencrypt. So basically, you encrypt the data, send it to the storage, let it be there, bring it back whenever needed, and when you bring it down, then you decrypt it. So it's a pretty neat feature. So this feature actually is built into the storage client libraries for .NET and Java so far. Other programming languages are coming and trying to catch up with this. Possibly very soon you're going to see those encryption libraries added to those too. So next, let's talk about encryption at rest. And that is when the data is actually just staying in the hard drives or SSDs or tape magnetic drives. There are some options to do so. Those options are storage service encryption or SSE, Azure disk encryption, and client-side encryption, which I'm going to talk about those briefly right now. So let's start with talking about SSE. This is a new feature currently in preview. This lets you ask the storage service to encrypt BLOB data when writing it to the Azure storage. This feature has been requested by many companies to fulfill security and compliance requirements such as HIPAA compliance requirements. It enables you to secure your data without having to add any code to any of your applications. Note that it only works for blob storage. Tables, queues, and files will be unaffected. That's important. Remember that. So you have to store as a blob. This feature is per storage account, and it can be enabled and disabled using the Azure portal. PowerShell, CLI, Azure storage account providers, and all the other APIs like REST API or the .NET storage client library. No matter which way you go for, you have to remember this is a per storage account item. This can be used with both standard and premium storage, but only with the new resource manager accounts. During the preview, you have to create new storage accounts to be able to try this feature. For older storage accounts, you cannot really try this as of now. So Azure Disk Encryption is another new feature that is currently in preview. This feature allows you to specify that the OS and the data disk used by an infrastructure as a service VM should be encrypted. For Windows, the drives are encrypted from the get-go, and they're encrypted with industry standard BitLocker encryption technology. For Linux, encryption is performed using dmcrypt, and Azure Disk Encryption is integrated with Azure Key Vaults to allow you to control and manage the disk encryption keys. And finally, the client-side encryption, as we already discussed, is basically same as we discussed it about the encryption in transit. The data is encrypted by the application and sent across the wire to be stored in the storage account, and when it's retrieved, the data is decrypted. For this encryption, you can encrypt data in blobs, tables, queues, and anything else rather than just blob like SSE. Also, you can bring your own keys or use the keys generated by Microsoft. So here's something to know. And if you store your encryption keys in Azure Key Vaults, you can use Azure Active Directory to specifically grant access to the keys, and this allows you to control who can read the vault and retrieve the keys being used for client-side encryption key. So as you can see, you can have a combination of these securities in place. Again, we will talk about security in more detail in future, but as of now, this is enough as far as you can have an idea about how security with Azure storage accounts is. You may want to see how people are actually accessing your account and using your storage account. Do all the requests you use in SAS? How many people are actually accessing the storage account using the actual storage account keys? How many are changing those keys? And anything else that you actually may be interested to know about how people do it. Uh, to check this, you can enable logging in the Azure Storage Analytics and check the result after a while. Enabling the logging tells the Azure Storage Service to log all requests to the storage account, and note that at this time, only blobs, tables, and queues are supported. The logs are stored in a container called $logs in blob storage, and they're stored by date and time. They actually are collected by hour, and if there is no activity, no log will be generated. So basically, you're not going to see any log telling you, hey, there was no activity. It's triggered by the activity and is saved by the time and the activity that actually happens. There are some different tags in that log, and we're going to go over those when we talk about the log analysis. And this concludes this video. See you in the next videos.